Hi, today we're going to look at the area of a parallelogram. So here we have a parallelogram. What's the definition of a parallelogram? Well, it's basically any shape where we've got a pair of parallel lines here, and then we've got another pair of parallel lines here. Notice I draw two arrows on this because I'm trying to say that they're not all parallel. If I was to draw a single one, then that would indicate I'm saying that this top line is also parallel to the diagonal line. Okay, so I need that. And that's it really. That's the definition of a parallelogram. So the question is, how can we find the area of this? Let's imagine we might know the dimensions of it. What could we do? And what we can actually do is a little bit of magic. We can take this parallelogram and we can cut it. So I'm gonna get my scissors out and cut it along here. And if I do that, whoops, that did not meant to happen, along here. If I do that, then I can then take, hey, I can take this and move it over here. And what shape does this now turn into? Drum roll. It's a rectangle. Okay, so we know how to find the area of a rectangle. We've been studying that, and that is base times height. But if we back at the parallelogram, we see that it has exactly the same base as the rectangle when I moved it, and it has exactly the same height. Technically, we call this the perpendicular height, but yeah, it's the height. Um, and so, if we want to find the area of a parallelogram, it's just base times height. Algebraically, A equals B times H. You can just write them next to each other because this implies multiplication. B times H, that's what this means. So that is something I want you to learn. But also to know where that formula has come from. It's really important for your understanding, not just to learn a bunch of formulae, think they just magically work. They don't magically work. They work because we can turn a parallelogram into a rectangle. Now, just to say, if we had a rhombus, then it would work in exactly the same way. A rhombus is actually an example of a parallelogram. It's when the sides are all the same length. In that case, you'd get a square. Or would you? I'm not sure if you would get a square actually, but you could still do base times, no, you wouldn't get a square, but you'd get a rectangle when you move it, but you can still do base times height. Okay, let's do some examples now. So how can we calculate the area of this parallelogram? Well, what we can write down is that the base is equal to 10, the height is equal to 6, and we can multiply them to give us A equals 6 times 10, or 10 times 6, give us 60 centimeters squared. Really important to put that unit of measurement in, so please make a note of that. Let's do one more here. This is still a parallelogram. Notice it's just been turned on its side, but if we identify it, they told us it's a parallelogram, we'll just do it in the same kind of way. I think I would, the base now is 3, okay? So you might normally think this is the height, but if we imagine turning it around, then the base would be 3, and the height would be 5, and you're still multiplying them. It doesn't matter too much. If you want to call this the height and this the base, that's fine, to be honest. Okay, let's keep going. One more question, because you're not always just applying a formula. Sometimes you have to think, oh, I've got some different sort of information that I now need to deal with. So this time we're told the area is 36, and we're told the height. Work out the length of the base. Now I'm going to do this by creating and solving an equation. A equals B times H. I know what A is, it's 36. I know what the height is, it's 4. So I can write B times 4. I can then rewrite that as 36 equals 4B. Okay, I just switch these round because actually that's quite a common thing to do. Put the number first, and then we don't need the multiplication, but it means there is multiplication. We're doing 4 times B. Now, we can use our knowledge of solving equations and divide both sides by 4. Okay, so I've got 4 lots of b is 36. So b is going to be 36 divided by 4, which you can either do with your times tables, or you can use a calculator. I don't mind. You get 9 centimeters. You might have done this problem simply by thinking, what do I multiply 4 by to give 36? And you might have tried doing it that way. But I think this is a powerful way that is worth getting into and understanding for more complicated problems in particular. Okay, so that is it. I'm going to give you some questions to try. So basically, the aim for today is that you know the formula for the area parallelogram, but you understand where it's come from. You understand why it's the same as the area of a rectangle. We can then calculate it for parallelograms like this, or ones that have been turned. We can deal with problems where we're given the area and we have to work backwards to find one of the sides. Maybe there's going to be multiple parallelograms, compound shapes, all that kind of comes into it. But we've done some 3 staple examples to illustrate the idea. Good luck with some questions.